Welcome all. Thanks all for joining. We will get started here in just a few minutes as participants trickle in. Just sit tight and we'll get rolling in just a few. All right, Vaclav, do you want to advance one and we'll get things started? Perfect, thank you. Good afternoon, everyone. Thanks for joining. My name's Ian Logan with 3C Ren and the County of Ventura. We are all here this afternoon for using LCA and embodied carbon calculators to make design and product choices with Vaclav Hasik. If you are here for this presentation, you're in the right place. If anyone would like, you're welcome to introduce yourself in the chat, maybe what firm you're with, where you're tuning in from. Otherwise, today, this is being recorded for our on-demand web page. If you'd like to remain anonymous, you can just stay off camera or not speak up. Otherwise, we will be handling Q&A through the chat. I'll be relaying questions as they come up to Vaclav. So if there are any questions, feel free to do so. And if we have time allotted, we can do a Q&A towards the end of the session. Next slide, please. So just a little housekeeping while we're getting comfortable. We are the Tri-County Regional Energy Network, also known as 3C Ren. We're a collaborative partnership between San Luis Obispo, Santa Barbara, and Ventura counties meant to improve energy efficiency in the region. We currently offer free programs and services for building professionals and households. We're funded by ratepayer dollars that we all pay into in our utility bills through the public goods charge. And the benefit of being ratepayer funded is that there's typically no cost to those we serve, and we're able to return those dollars back to our local economy instead of being distributed throughout the state. Next slide, please. So our three current programs are our Energy Code Connect program, where we offer industry training, regional forums, and a Title 24 consultation service called the Energy Code Coach. If you ever have any Title 24 questions come up in the field or on site, you're welcome to call this hotline or submit an inquiry form on our website, and you will hear back from one of our local code coaches in 24 hours. Our next program, the Building Performance Training Program, and the reason we're all gathered here today is where we offer trainings on technical and soft skills related to building science principles and systems for high performance buildings. Our goal with this program really is to bring industry recognized certification and training providers to the Central Coast that'll help advance people wherever they may be at in their career. And then lastly, our Home Energy Savings Program, which serves households that are historically underserved with free and discounted home energy upgrades for any multifamily property owners or contractors that are interested in participating. Please reach out, or you can also fill out an inquiry form on our website, 3cren.org. With that, I will hand things over to Vaclav, and thank you.
Great, thanks, Ian. And hi, everyone. I'm very happy to be here, and I'm excited for this session. It's, as the description said, it's planned to be a pretty hands-on session. We'll be going through some of the tools that were listed live. And so I'll also leave enough time for everyone to potentially open up the tools as we go through the course, and also just open up the floor for any questions as we go through everything. It may be a lot of information, it may be a little bit of drinking from a fire hose. So if you need me to slow down, let me know. But otherwise, we have the next about an hour and a half planned for this session. So we'll be going through 3 different tools in a lot of depth. but there will be also other tools that I'll mention that you can also use depending on the use case that you need for your particular projects. So just to kind of add to my introduction, I'm the program director at Building Transparency. We are a nonprofit organization focused on providing open access data and tools that allow the architecture, engineering, and construction industry to address aspects around climate change, especially around the embodied carbon footprint in the production of materials. We want to make the manufacturing aspects, the low carbon manufacturing aspects of different manufacturers to be a competitive advantage in today's market, so that there is more investment in low carbon technologies, and we reduce the embodied carbon footprint that's associated with buildings and infrastructure. Again, we are a nonprofit organization, so we are funded through donations and grants, and so I just wanted to recognize the support of all of the companies that are listed on this slide. I won't have to spend too much time here, but again, this session is meant to be more in-depth, hands-on experience with some of the embodied carbon tools. This is not a, sort of as much high-level overview of embodied carbon and life cycle assessment, although I will go over some of the basics in the first few slides. But I think there was another course organized by this group that touched on most of the basics, on the different environmental impact categories, and some of the details of what life cycle assessment really is and what embodied carbon is. So the focus today will really be going deep into the three main tools: EPIC, Tally, LCA, and EC3. But as I mentioned, I'll also cover or touch on a couple other things. So in terms of the agenda, again, brief intro, and then we'll go through the tool by tool based on how they fit into the design and construction process. So we'll start with the EPIC tool, which is really most useful for the conceptual design and planning phase, when you don't have a lot of information about the actual details of a project. Then we'll look at Tally LCA in detail. Tally LCA is a Revit plugin. So that one, you won't be able to use unless you actually have Revit, but there are a couple of other tools that are available for anyone that doesn't have Revit interface. You can still do life cycle assessment analyses in the schematic and design development phases. Also, the tools, this is not something that I mentioned, but all the tools that I will be covering today are free to use tools. There are also paid tools that you can use. For example, one-click LCA that cover various parts of some of the features that you will see today. You just need you need license, that there are associated license fees, and the user interface and the experience is slightly different. But generally, you're still trying to, you're still going through the same process of collecting information about the design, information about the products, and connecting the material quantities with the embodied carbon factors. The last tool that we'll cover today is the EC3 Embodied Carbon and Construction Calculator tool, which is really focused on the later stages, specifically construction and product procurement. That tool can also be used earlier in design, and I'll show you exactly how, but it really was conceived from the contractor perspective and from a perspective of actually looking at very specific product types in very late design stages. As I mentioned, there are many other tools, so we obviously can't cover all of them today, but I hope that all the ones that we cover today, since they're free to use, most of them, that they will be actually useful for you on your regular basis. If there's anything you take away from today, I would like for there to be at least one thing that you take away from today that you can take to your actual practice and start implementing into your design and construction process, one at a time, essentially, in terms of trying to lower the carbon footprint of whatever you're working on, residential buildings, commercial buildings, even in infrastructure projects. So let's start with the intro to LCA, and again, this will be relatively high level. I will be, throwing these terms around, so life cycle assessment or LCA, is the general approach to quantifying the environmental impacts of product and processes. And I have another slide on the next slide that goes over the various life cycle stages. Again, this is going to be very high level. Whole building life cycle assessment is the same exact, approach to quantifying environmental impacts, but specifically to buildings. And specifically, it's typically connected to tools that have specific features for architects and engineers to help quantify the amounts of materials in a project. Then I will probably throw around the term EPD, or Environmental Product Declaration, which are the product level environmental impact assessments, actually the results of these product level LCAs that you can also use to select specific, hopefully low carbon products. And then lastly, GWP is the embodied carbon footprint metric called global warming potential. So when you hear about embodied carbon and global warming potential, those are essentially equivalent. Embodied carbon is just specific to specific life cycle stages of products and buildings, right? So it's anything that's associated with the production of materials, construction of a building, maintenance and replacement of specific products, and then also the end-of-life disposal. Those are all the embodied carbon aspects. But also obviously operational carbon aspects that can also be measured in a global warming potential. But there's that differentiation between what comes from materials and what comes from energy, electricity, natural gas usage during the use phase of the building. Now, again, at a high level, what life cycle assessment does, there is a collection of emissions of various substances. For global warming potential, those are specifically greenhouse gas emissions, right? Like methane, carbon dioxide, nitrous oxides, hydrofluorocarbons, etc. And those emissions are calculated or collected for the production of specific materials, as well as through construction processes, transportation, etc. And at the end, everything is collated to a single equivalency unit, which is the kilograms of carbon dioxide equivalents. Now, this is again to kind of bring the impacts of production, raw material extraction, and end-of-life disposal impacts that you may not necessarily see on a construction site directly, but those impacts are still very real. And according to, you've probably seen this metric as well, but according to I think it was Architecture 2030 a couple of years ago, put out an overview of the embodied, or the carbon footprint of buildings and infrastructure, or essentially all activities related to human activities, right? And carbon footprint of buildings accounted for 40% of all of the human activities around the world. About 11% was from the production of materials in that assessment. Now that number is actually probably a little bit of an underestimate. It's not super straightforward to actually calculate and assign specific production or material production impacts to just buildings specifically. Again, at the end, the goal that we have here is just to be able to calculate the footprint that is related to infrastructure and buildings, especially the materials that we'll talk about today, because without calculating these impacts, we actually can't even reduce them if you don't know how to, right? If you don't know where the largest opportunities for reductions are. So this is why these embodied carbon calculators are essentially existent today, and that's why you see more and more of them in existence. Now, the last intro slide to life cycle assessment, and specifically to whole building life cycle assessment, is this one. So life cycle assessment in of itself can get really complicated when you're talking about the production of specific materials and the connections in the supply chains, etc. On the building level, it's relatively simple. All you need is the quantities of materials, and then the impact factor, or the global warming potential factor for the product that you're actually putting into your building, or that you're considering putting in your building. And so these various tools that we'll talk about today mostly have features that allow you to streamline the estimating of quantities in your buildings, and they also provide you the libraries of impact factors for the most common materials that you can put into your building. Again, the equation is really simple. It's just multiplication of the quantity by the impact factor. And with that, we'll switch over to the actual hands-on part of this course. We'll start with, yes.
Real quick, we have a question from Chris. If whether or not refrigerants are included in the embodied carbon calculations.
They are. So they actually would be part of the use phase emissions. I didn't actually include the full outline of the stages here, but there are about 6 or 7 different subcategories under use phase. And there's the B1 use phase direct emissions in a building. And that's where the direct emissions of refrigerants, any leakage of refrigerants should be accounted for. So it would still be part of the embodied carbon aspects, even though you could say that it's more operational.
Very good. Thank you.
Any other questions before we go into the next phase, which is this is going to be the first phase of the actual walkthrough of the tools.
That was it in the chat.
That was it? Okay, sounds good. All right, so we'll start with logically the first step, and that is the planning phase, where you may not know exactly what type of materials and assemblies you're putting into your building, but you may have a general understanding of the use type of your building, the general size and location of your project. In all of the life cycle assessments of buildings that you will do, you will always actually need very detailed information about the assemblies and materials that you're using. And so it can be actually kind of hard to do a robust life cycle assessment up front. We haven't really had good tools to address this phase for a long time. But luckily, last year, I think it was last year, the architecture firm EHDD released this EPIC tool, which helps you put in basic information about a building and get a first understanding of what the typical embodied carbon impacts and operational impacts of specific types of buildings can be. This tool, how it works, is EHDD collected data from many different buildings that they've worked on in terms of the structural material quantities. And they sort of, collected the typical amounts of structural, concrete, steel, mass timber, etc., in the structural frame of buildings of different types. But they also collected a set of assemblies for envelopes, interiors, and you can see here that they also include systems such as MEP systems, etc. So this is all based on historical results, and there are various aspects of this tool, which I'll show you in a second, that help you also preliminarily analyze, hypothetically, if you were to choose specific type of structures or specific type of design strategies, what the initial expectation of reductions or increases of embodied carbon could be. So with that, we will be looking at a specific hypothetical project here. I am actually using one of the Autodesk Revit sample projects because we'll later on be looking at a specific Revit project. But here are the basic information about the project that will now be entering into this EPIC tool. So we'll be talking about a educational building. It's going to be a high school building of about 5,000 meters squared gross floor area. The expected building lifetime for the entire analysis will be 60 years, but there is a caveat with the EPIC EHDD tool, which only looks at a 30-year lifetime. There are differences for the calculation of the replacement impacts of specific materials. For those replacement calculations, you need to understand the service life of specific components, and then you need to understand what the total expected building lifetime is, right? So that's where that 60 years is important. It's also a 3-story building, and so we will have on average about 1,670 meters squared of floor area per floor system. So now that we know the basics of this building, let me switch over to my browser. If you wanted to follow along, I will actually drop the direct link to this tool into the chat box, and feel free to follow along. The address is epic.ehdd.com. Now, I've already logged in, so if this is your first time logging in, you will need to register for this tool. But once you're inside of the tool, I already started a couple of projects. I was actually practicing right before the session, right? So I have a couple of projects here, but I'll also start with a completely brand new project to walk you through all the steps. So at this point, we'll select new project, and the Epic tool is just saying that all of this is based on historical data and some assumptions that the EHDD team was making. So this is obviously not a prediction of the future. It's more of a helpful tool to help you understand what typical other projects historically, what the impacts have been in terms of the embodied carbon footprint as well as operational carbon footprint aspects. So here we just logically just enter basic information about the project. Call my project 3CRN project. You can enter the approximate construction or project completion date. It's not super important actually in this case. I don't think there's any specific prediction of the operational carbon footprint of the electricity grid. So this is more for just a bookkeeping exercise, right? For understanding when the project actually is expected to complete. You select the country. Right now, this is focused on North America. And then the location of the project, because it does actually take into account the differences in the electricity grids around the country. Now, my focus today, again, will be on the embodied carbon footprint side of things, but this tool will always show the operational aspects as well. In terms of the baseline structural system, you have a couple of options. I will stick to the reinforced concrete option, and then we'll show what some of the other selections of the structural system, how they actually affect the predicted results from this tool. Primary use will go into the education. So we'll do K through 12 school. That's the most equivalent primary use that we can select here. And the number of above grounds, again, is 3 here. And the area per above ground floor is about 1,670 meters squared. Now, the tool actually wants this as square feet. So I will go back to my table, and it's about 18,000 square feet. So we'll enter that here. Oops. Right. 18,000 square feet. Okay, and then for the below ground floors and area per below ground, we'll just keep it simple. In this case, I actually don't have any basements, but if you had some, obviously you could add that. Okay, so now we have the basics of this building defined. And I think that's it that you actually have to input. You can include the project description, but otherwise this is all that you need to input. And you can see that right away we get some estimates of the total embodied carbon footprint, 4,000 tons of CO2 equivalent. And we also have that operational carbon footprint. And we'll come back to carbon storage. This is specifically relevant to any bio-based materials that may be in the building. Okay, so now let's scroll to the bottom of this page. You can also include site and landscaping here. In my case, I will again just be focusing on the building, because in the later tools, we will again just be focusing on structure envelope and how to optimize the design from that perspective, as well as how to select specifies low carbon product from specific manufacturers. If you wanted to, you could actually override some of the default epic assumptions. This is specifically around, I believe it's the type of envelope systems that are included. You can, for example, modify the envelope of this hypothetical building to actually use all low carbon products from the get-go. And so if you wanted to, you could override some of the defaults. We'll actually go through some of the specifics as we start defining the reduction scenarios of this building. But at this point, this is all you need to do to get the initial estimate of a typical building of this size in this location. Now, the next step would be to actually start understanding how different designs or various broader design decisions might actually affect the embodied carbon footprint of this building. So I clicked on the reduce emissions section, and here we can start defining the first scenario for comparison. So in my case, I'll actually save this as a base case, just so we can come back to it and show you the analysis of the embodied carbon budget by the different systems within the building. We'll have to come back to this again. So for now, I'll save this base case and I'll create a new scenario. And we'll start with a new empty scenario. This will just take the base case with all of the default settings and create a new scenario that we can now modify again. Okay, so now we'll look at another broader decarbonization measure, and that will be actually reuse. So you might not know this, but I'll just start with this. Reusing structural systems that use high amounts of concrete and steel is obviously going to enable you to reduce the embodied carbon footprint of your project very easily, because you're essentially avoiding the remanufacturing of some of these high impact materials. We'll look at a scenario where we reuse the structural system specifically. So I'll name this scenario reuse. Actually, reuse structure to be specific. And right now we can just use this slider. It's again very easy to use. And let's say we reuse 85% of the structural system. And I'm using this based on one of my projects that I worked before, where I worked on an adaptive reuse project where we reused pretty much the entire structural frame of a building. And in that particular project, we were able to reduce the embodied carbon emissions, or essentially avoid about 75% of the embodied carbon emissions. In our case here, if you reuse 85% of the structural system, you can see that we achieved a reduction of 1,430 tons of CO2 equivalent already. So it's not quite 75%, but the reason for that is because, again, this is including a lot of other systems that I didn't actually include in my previous estimate. My previous estimate was in structure and envelope. This is including MEP systems, interiors, and other things as well. So again, this is a first way of you actually understanding where some of the low-hanging fruit in terms of decarbonization measures can be. You can also do the same thing, right, for roofing systems and obviously the cladding as well. And some of those reuse aspects will also help you reduce the carbon footprint of the building, but the structure is really the bulk of the impacts here. I'll put this back at 0, and I will actually save this scenario, and actually auto saves, but I will want to explore other decarbonization measures. And so I will start creating additional scenarios here. So we'll click on that new scenario button again, start from scratch. This will put our structure use back at 0. So now let's say we weren't actually able to use or reuse existing structure. We'll go and consider maybe an alternative structural system. So far we've been using reinforced concrete frame. So what about if we use steel frame? Type that scenario name here. and scroll down to the embodied carbon of the structure and change the primary structural system to composite steel frame. I'll click away so that the project is safe. Again, you can see slight reduction in the impacts here, 230 tons of CO2 equivalent, but it's obviously not as big as reusing the structural system. Okay, so now let's try and see what mass timber impacts would look like. So we'll create another new scenario, new empty scenario. And back under the embodied carbon structure, we're back to the default, which is reinforced concrete. We'll click on mass timber, click away. And again, you see a little bit of a reduction, but not too large. So you see 210 tons of CO2 equivalent. Usually bio-based products or wood-based products do have lower embodied carbon footprint because the production impacts or the direct emissions during production are not usually as high as steel and concrete. In this case, for some reason, the reduction actually wasn't that large. It may be because the amount of mass timber actually needs to be larger than some of the other materials to support the same loads within the building. But that's currently just a hypothetical, hypothesis that I have. Again, this is based on historical amounts of material quantities for specific structural systems. So when you're looking at specific these designs later on, the numbers might vary a little bit more. Now, okay, so let's say we also wanted to specify that this mass timber was actually procured from responsibly sourced timbers, so something like an FSC product. And in this case, I'll create this as a new scenario to be able to show you the differences in those final results later on. In this case, I'll actually copy the current scenario with the mass timber structural frame so that we don't have to make that selection again. But we will add the differentiation here that the mass timber frame is actually with FSC wood that has chain of custody certification. In this case, if you click on the procure responsibly sourced timber here, you can potentially claim additional reductions, basically the amount of carbon sequestered in the wood itself. But you need to understand that in order to be able to take that credit, or in order to be able to, tell people that there's actually sequestered carbon in your timber, you need to make sure that that timber is sourced from sustainable supply chains, from sustainable forests. So essentially, this tool is just telling you, you want to make sure that you do your due diligence when you're sourcing the materials, that it checks all these boxes. This is essentially saying that you cannot claim that carbon sequestration unless that wood in the forest is actually, replanted and that tree can regrow in the forest. This is to ensure that you're not contributing to deforestation, essentially. This is a little bit of a tricky topic, so that's why this checkbox system and not something more sophisticated. There are currently still ongoing standardization efforts and accounting methodology efforts around standardizing the way that sustainability of wood is actually captured in EPDs and life cycle assessments. So these checkboxes and your individual due diligence is all you can do here. And you can see that in this case, we actually get this yellow negative value, which is called stored and avoided emissions. And in this case, it's about 760 tons of CO2 equivalent that actually gets stored in the building in that mass timber. Okay, so now we've explored a couple of different scenarios. I think I saw someone in the chat actually asking about low carbon cement products. And the answer is that there is an option in Epic to select low carbon concrete specifically, or at least lower carbon concrete, but you can't select specific product types. So I think Sublime here That's a specific type of product from a specific manufacturer. You won't be able to actually select that specific product, but you will be able to try and see what a low carbon concrete would do if you were still, for example, using that concrete frame. So we'll go and create our last scenario for this analysis. We'll click on new scenario here, new empty scenario, and we'll say low carbon concrete. We will stick with the reinforced concrete structure, but here under concrete specification, we will actually say low carbon. So 20th percentile will essentially lower the emission factor per unit of concrete on the project to one of the lower impacts concretes. And in this case, again, you see a little bit of a reduction of 170 tons of CO2 equivalent. So not as big as reuse, but it is, it is going to be significant when you start looking at just the structure and just the concrete specifically. You can probably lower the impact by about 20–30% just if you're looking at just concrete on this project. We'll get to some of the specific amounts of reductions per material type towards the end of today's course as we start looking at specific product types using the EC3 tool. So we'll come back to this again. Now, I mentioned earlier that when you're looking at these different scenarios in the Epic tool, you can switch over to the embodied carbon budget section. And here you can see the impacts from the specific systems within the building. And this is going to be important later if you're trying to actually compare your early Epic estimates to other estimates using other tools. You will want to make sure that you align the scope of the analyses as much as you can. So for example, later on, we will be looking at impacts from the structure and envelope only. And so in those cases, if when you're doing the comparison, you would want to take only the structure and envelope impacts from this Epic tool. You also want to make sure that if you're including some of the other life cycle stages like transportation or replacement of materials during the use phase of the building, that you also align some of the other assumptions between the tool. So for example, here I mentioned that the Epic tool uses a 30-year lifetime. Some of the other tools that we'll look at today, such as Tally LCA, those by default use 60 years lifetime for calculating the replacement of materials. You can modify it though, so you just want to make sure that you always compare results using the same setup, same assumptions, same scope of the analysis. And you probably already noticed without me even talking about it, but here on this timeline chart of the project, you can see that the embodied carbon emissions, start at the high level at the beginning, and then they don't change for a couple of years until about this year. So I think it's about 2033, 2034, where some of the materials probably in the interiors start being replaced. And so you have this a little bit of a bump up in the embodied carbon emissions at that point. And that happens multiple times during that 30-year lifetime of the building. And then at the end, if you're demolishing the building and getting rid of all the materials, that's where you have that larger bump all the way at the end of this whole analysis. Now, okay, so we defined a bunch of scenarios and we looked at the reductions for each of them one by one. Now, let's take a look at them all at once in this compare section. So now I click on the compare button here. You can see the base scenario right away. And then you can see the other scenarios that are selectable down here. So we had the copy of the base case, reuse scenario, steel frame scenario. This one I didn't actually rename, but I think that was the mass timber scenario, mass timber FSC, and then low carbon concrete. Well, I'll start enabling or essentially showing all these scenarios. now you'll be able to see side by side how they actually compare over the full 30-year lifetime of this project. You can see that the reductions are not all that great, but again, if you only look at the structural systems, for example, those are actually some significant reductions there. You can also look at it by category, and so you can again see the differences in the embodied emissions in the pink here a little bit nicer. You can see that the reuse of the structure really had the largest change for the embodied carbon aspects. And again, you haven't really touched the operational emissions, but if you wanted to use this for a holistic carbon footprint analysis at the planning stage, you can make some additional tweaks for the operational aspects. Now, at this point, if there are any questions so far on the use of the tool and how you basically get the initial estimates of the embodied carbon footprint, let me know. Otherwise, I will switch over to a Word document. So where some of this, let's see if there's any questions first. Is this program accessible free of charge? Yes, it is. So most of the tools that I'll cover today are accessible free of charge, or at least have a free trial. Okay. I think some of these other questions on specific types of materials we'll be able to come back to later as well. But what I wanted to mention here is, okay, well, you have this planning tool. Where might you be able to use it in terms of your basis of design or contract language? So this was actually a template document put together by our Owners CAN group, Owners Climate Action Network group, which is a group of owners and other stakeholders that manage large portfolio of building projects. And they all wanted to, kind of share their resources for how they come up with contract language and how they actually communicate the intents of addressing, first of all, capturing the embodied carbon footprint of their project, but then also addressing it, right? So this is where you could actually plug in some of the early estimates of the embodied carbon footprint from the EPIC tool. You could start setting some sort of high-level goals for the amounts of kilograms of CO2 equivalent per unit area of your project. You could start plugging those numbers right here into the basis of design or the contract language. You will see that part of this template, there's also a definition of what's within the scope of the study. And this is, again, just to communicate clearly and consistently to the design team as well as the construction team what sort of materials are expected to be tracked on the project and what's included in that initial estimate of that kilograms of CO2 equivalent per square foot that the owner is maybe trying to address, right? You can also see that this specifically focused on the stages A1 to A5. So it's not actually addressing any of the replacement or end-of-life disposal impacts of the project. So I will provide a link to this particular template. Feel free to reuse it, on your project if it's relevant to you. But I just wanted to point this out because this is, a lot of people ask, well, where do I get this number if I don't have a detailed design yet? Now you have the EPIC tool that helps you at a high level quickly estimate the potential carbon footprint of similar projects without actually defining any assemblies and defining any material selections. All right. So let me switch over to the PowerPoint presentation again. And we'll switch over to the next phase of design, which is typically design development and schematic design, right? So this is where you might start actually understanding more of what the individual assemblies on a project are. Some of you may be using Revit, which is what I'll start with today, but I'll also show you some tools where you don't need have a Revit model. You can still do some of the more detailed and specific analyses once you start having more specific idea about the design of your building. You can do these embodied carbon assessments in a variety of ways. The first tool that I'll walk through is Tally LCA. This is our own building transparency tool. It was actually started by an architecture firm out of Philadelphia, Kieran Timberlake, around 2016. So it's been around for a while, and it's really focused on making this process of assigning specific material impact information to a Revit model very seamless. And also it provides a nice library of specific material types, and then has a nice, pretty comprehensive, but also not overwhelming report, I think, for anyone that's trying to address life cycle assessment on embodied carbon for the first time. So what this tool does is it takes some of the existing dimensional and material information from a Revit model. It allows you to connect the Tally material library to individual elements within the Revit model, and then generate these Tally reports. So I'll switch over to my Revit interface. By the way, you can download Tally LCA. Download Tally LCA here, so I'll drop that in the chat. And again, there's a free trial. I think it's about 10 days, but we can also extend that trial. Otherwise, there is a small license fee here, and that's basically to pay for the underlying lifecycle assessment data. We are currently working on overhaul of the database and hopefully make the whole tool free to use in the future. But right now, there is a relatively small cost to it. Okay, let me switch over to my Revit interface. Now, again, if you have Revit, you can follow along. If you don't, I think that should be okay. You will still be able to see how I go about all the steps. And I'll actually start a new project just so we start completely with a blank slate with something that you may be starting in on your end if you're following along. And then I'll come back to this full building to kind of show the overall analysis of something more complete. But essentially, I'll start with a architectural template here. And again, the idea is to take all of the native features of Revit in terms of modeling, and just add a little bit of a additional feature in terms of the environmental impact assessment using the Tally add-in. So at this point, I'll just do a simple example where I'll place a couple of wall systems here. So I'm placing one of the basic generic walls. Again, you don't need to actually define any of this yourself. If you're starting with a blank slate in Revit, you will have some predefined families already available. I just clicked on another wall system, and we'll add another type of wall into this project. So we'll do, for example, this exterior brick on metal stud. And we'll just do same section of the wall, and that be it. Look at the consistent colors here. And can't really see right now that there are multiple layers, but if I actually click on one of these wall systems and then go into the edit type section, and then into the structure section, you will see that this wall system has about 7 individual materials within it. And you can see that there are specific thicknesses of each of these materials. So we have brick, air barrier, plywood, metal stud layer, vapor retarder, and gypsum wallboard. So again, this is the way that the Revit wall family was actually built. Okay, now the other wall system, if I click on it and edit type and go into structure, you can see that this one only has 1 layer. That's just the basic generic wall. And it actually doesn't have any material assigned to it, at least the Revit material. So we'll just leave it at that, but just keep that in mind as we switch over to Tally LCA. Now, to start Tally LCA, you would go into the add-in section here, and you can go into the Tally LCA. We'll have this colorful icon here called Tally. You can click on that, and it will bring up the Tally LCA plugin. Now, when it says downloading updates, that is the only time that the tool actually goes into the cloud. It's downloading all of the materials in the Tally library and the associated environmental impact information that's in our database. When you're actually working on your projects, all of that project information just stays within the Revit file itself. It's not actually sent anywhere outside of your computer. It's not stored in any of our servers. Sometimes I get that question from Revit users for security purposes. So all of the information stays with the Revit file, and you will want to save the Revit file itself in order to save all of the lifecycle assessment work that you're doing in Tally. The first step in Tally LCA is selecting the object of the study. So the most typical object of study is going to be full building study. This essentially just takes an account of all of the placed elements in the 3D space, and then you will be able to assign material information to the individual elements. The next step is selecting the scope of the study. So again, like I mentioned before, right, you have structure, envelope, interiors, MEP systems, site elements, etc. The list of categories that you see here is the scope, the full scope that Tally LCA is capable of helping you assess. So it doesn't actually include any MEP systems. There's a reason for it, because a lot of the MEP equipment is very specific to different types of systems and different types of manufacturers. There's not actually a whole lot of publicly available data on the amounts of quantities of different materials and the actual carbon footprint of these products. It's changing now, but it just isn't widely available. So it's not in most of these more detailed whole building life cycle assessment tools. It's probably going to change going forward, but at this point, this is mostly focused on structure and envelope and some interior components. So I'll just select everything. We only modeled two layers of, or two types of wall systems. So some of these categories are not necessarily relevant, but I'll just select everything. You can also select the scope by using work set settings in Revit. And you can also select phases creating settings. If you're familiar with Revit, that probably rings a bell. But essentially, each element in the project you can assign to specific, almost like layers of the project. And then you can include or exclude based on some of those characteristics that each element has assigned to it. Once you select the scope of the study, click on Apply. Now the tool is collecting all of the dimensional information for the various elements that are placed in the 3D space. And the next step is assigning material information from the Tally library. So you go and we can see those two families that were placed here. And if I open up these triangles, you can see the individual layers within that family. So this is what I meant when I said that you do need very detailed information for being able to do the life cycle assessment. Each of these layers is going to have very different mass, very different volume, and very different environmental impact information, right? And so you do need to understand each of the individual layers in a realistic wall system. You see that in this generic family, we do still see that one layer, but it doesn't actually say what the material is. It just says by category. And so I'll show you how you can address an assembly like this. But the next step would be, again, assigning specific materials from the Tally library. So you can right-click the individual elements, click on Edit Definition. And now we were looking at a brick element, right? So I could go into masonry and I could just try and find brick in the library. where you can type in brick in the filter here, and it will find you a couple of different types of brick that you could select from the tally library. In our case, we'll select brick, click on apply, and then on the next window, you will need to select a more specific type of brick, because again, even within just saying that you have a brick, there are many different types with different manufacturing processes, so the impacts can be different. If you don't know which type of brick you should select, the first one is usually the most generic data source that you can use. You can select various service life. This is again for calculating the replacement impact, so we'll just keep that at default. And then you would also select the takeoff method that you want to use to get a realistic quantity takeoff for this type of material. As you may know, in Revit, some of the modeling is simplified. So sometimes you just specify what the thickness of a layer is, but there is no understanding that, for example, studs are not actually the full volume of a wall system. They're actually thin amounts of metal spaced a certain amount of distance from each other. So Tally LCA helps you address some of those specific and realistic way of quantity estimating some of the material types. We'll go through studs specifically in just a second, but this whole interface is set up to help you define the additional information you need to get the accurate quantity estimates for your building. So in this case, you usually have multiple takeoff methods you can do. If you think that the actual modeled Revit, the modeled layer in Revit is accurate to how the product actually is produced, then you can simply use the takeoff method that is typically first or the most straightforward. In this case, you could just take the full volume of that one layer and assume that it's a solid brick, right? In our case, we actually specify the joint type for the bricks as well to be able to account for some of the additional spaces within, between the bricks as you stack them on top of each other. So in this case, you can see that it's not actually taking the 100% volume that's modeled in the Revit family. It's taking a specific percentage volume that was predefined in the Tally tool. If you wanted to change this, and maybe you knew specifically what the volume should be for your particular project, you can always manually override some of these settings. So we could just say 100% by volume if we didn't want to account for any of the external aspects in the quantity takeoffs. I'll go back to the 3/8-inch joint just to keep it sort of standardized. You can also add additional accessory materials. So something that's not modeled in Revit, but that's realistically there is the mortar, right? So you can select different mortar types. I'll just randomly select some of these. You can do by volume again, and then we can select the same joint size here. And that fills in the rest of the volume of the wall system with the mortar. You can also add grout, again, just the same exact way. Different takeoff method options. And in this case, it's taking it into account 16% by volume. And you can also add reinforcement, etc. I think you get the point at this point. You can add additional materials that would be within the brick layer in a wall system. We'll do some predefined reinforcing amounts, and then for finish, I actually won't. I don't want to add any finish, so I just click on the none selection here. Save that definition, and at this point, this will turn green. That means we've addressed that layer. And you can see the amounts of individual materials in terms of mass. You can also see the takeoff methods that we used and how we defined the materials. You can see the full list of individual accessory materials added. If, for example, you have something like this, where you have air, it's essentially just an empty layer, you can set this layer as a dummy material, that essentially means there are no impacts associated with this layer, but it just means that you've checked it off the list and you can keep going down in terms of defining additional material types. I will define one more type. So this metal stud layer, I mentioned that earlier. We'll click on that, edit definition. I'll search for stud layer, T-stud metal framing. There's also an option with insulation. So you can either have just the stud or you can have the void filled with insulation here. I'm just going to go for the regular stud without insulation. At this point, I can select the material type. Again, the most basic one is the first one. And in the takeoff method, instead of doing by volume, which would just take, again, the full volume of the layer and grossly overestimate the amount of metal, instead I'll do this takeoff method by spacing. And so in this case, I can select from a predefined list of stud profiles. In my case, I don't actually remember what the actual model thickness of the wall system was, but let's say it was 3 5/8 inch, 20 gauge stud. Now I can select the spacing and I can include or exclude perimeter members here. So let's say it was 16 inches on center. I can save that. Come back here and we have 209 kilograms of cold formed structural steel in the framing based on those definitions. Now, if I wanted to actually compare, so the layer thickness is about 6 inches. So this actually doesn't quite match up with what the modeled thickness of the layer was. So I could go back, right click it, edit definition, apply. And I could actually specify that the profile was more like 6-inch stud, 20 gauge. Save. And you can see that this is 987 pounds of cold formed structural steel. Actually, I've been switching between imperial and metric units, and apologies for that. There's a lot of overlap or changes and mixing of the units that you will see in life cycle assessment, unfortunately. But most of the tools try and give you tools to be able to switch from one unit system to the other. So I think originally we had something like 200 kilograms of cold formed steel. Now we have 448. You can see almost double the amount. Again, just to make the point clear, if I went back again, did a takeoff method by volume, just did 100% by volume, I get 114,000 kilograms of cold formed structural steel. So that's obviously incorrect. So this is just, a couple of the features that the tool has to help you come up with the right quantity estimates in your project. In this case, with the assembly where we didn't actually have specific layers, I won't be able to edit definition here because the Revit material is not specified. So either I would need to select that element and then go back and edit the type in Revit and select the specific Revit material, or I could just add additional accessory materials in Tally LCA without actually modeling anything in 3D. So I can add accessory material, say that I have, again, say we have a stud layer, and now I can go through the whole stud layer definition process all over again without actually having anything modeled in Revit specifically. So you can start doing some of these assessments even in early design before actually having any of the layers fully defined. You can start exploring what the impacts could be. So now that we've walked through the basics of how to define materials, are there any questions so far? I'll switch over to the fully defined model and start actually looking at some of the results from Tally LCA. But if there are any questions so far on the material assignment portion, feel free to let me know.
Oh, here we go.
Can you
One
upload,
just
yeah, can you upload EPDs to Tally LCA? Currently, no, there are a couple of EPDs, as you probably noticed, but those are more legacy EPDs. Tally LCA is focused on, again, the earlier design phases, and it's really focused on giving you an assessment of the average impact of individual materials based on the general market conditions. So most of the EPDs that you will see here are going to be industry-wide EPDs and industry-wide, industry average impacts of the individual materials. You won't see too many product-specific EPDs. And this is kind of a longer topic, but there are just some issues in making sure that the environmental impact categories and all of the background assumptions behind the EPDs align from one EPD to another. When we talk about EC3 later, which only focuses on the carbon aspects, it's a little bit easier, or it's more appropriate to actually look at just the carbon footprint impacts from one EPD to another, because the carbon footprint impact category is pretty well aligned across all of the EPDs and all of the category rules that are out there to govern the EPD system. When it comes to the non-carbon footprint impacts, which you'll see in a second, like acidification, eutrophication, etc., the life cycle assessment systems is more over the place, and there isn't a clear translation or conversion that you can do sometimes from one unit of, let's say, acidification to another unit of acidification. But again, it's a little bit larger topic. What we actually plan to do with Tally LCA in the future is give a carbon footprint specific option potentially, and in those cases you would be able to use some of the EPD data. Again, we'll come back to using product specific EPDs when we start talking about the EC3 tool as well. Okay, so now let me switch over to the fully defined model that I have here. So again, this is the Autodesk Elementary School sample project that you can access yourself as well. So if you wanted to try this yourself on a sample project, you could try and define the whole project yourself as well. I'll reopen Tally LCA here on this project. I'll go into the full building study. Again, select all of the categories, all of the work sets. You actually see that I have more work sets defined here. And I also have a linked model, the structural model that is shown here. So I'm now including a separate structural model as well as the architectural model, which focuses on the envelope and some of the interiors. Click on apply. Now this will take slightly longer than the last assessment with just the two wall systems, just because we have way more elements in the project. But even on large projects, this shouldn't take more than about a minute. At this point, you can see that we have more of these categories here. The linked model I can see, but I cannot modify the elements. So if you wanted to, for example, change the definition of the cast in place concrete in the structural system, you would have to open up the original structural model to be able to edit it. Once it is edited, you can generate results or create results from both models all at once. It's just the editing part that is not accessible here. And you can see that all of my categories are green. That means that I've defined all of them, all of the individual layers, except for the wall system. So it looks like I didn't finish something here. So this would be a quick way of me actually seeing, yes, there are a couple layers that were not defined. I should probably address them. In my case, I'll actually skip over this, and I want to get to the results part of the tool so that you can start understanding where some of the contributions from an embodied carbon perspective are coming from. So we'll go over a save report here. Now here you fill out similar basic information about the project as we did in the Epic tool. So You have the title of the building, author, project address. You can add an image as the cover. And you do want to fill out the gross building area, because once you start comparing to other projects, or even once you want to compare to the initial assessment of the Epic tool, you probably want to do that on a per unit area basis, a typical way of comparing results. And again, you have the expected building lifetime here. The default is 60. You can make this any number that you want. But again, for something like, let's say, LEED certification, they will actually ask you to use 60 years. Most of the certification schemes will ask for 60 years. And then in the goal and scope, you would just describe exactly what you were doing in this assessment. For example, was this an early design development assessment where you just quickly was trying to fill out all of the individual layers? Or is this more of a construction documentation phase where you've actually gone through each layer, documented or cross-checked everything with construction documentation? And so essentially this is more of a actual design that you are then handing over to the builder, right? So you wouldn't want to specify all of that here. I'm just gonna type in test and skip over that. The rest of this section is more about just specifying what actually shows up in your final report. You can include construction impacts, but you do need to enter the final amounts of quantities for fuels that are used on the construction site. You can also include operational energy impacts, but again, you would just need to have the total EUI from something like an energy model. In my case, I'm going to skip these two things and I'll keep everything at default. And to generate a report, you would click on Save Report here. So we will save a building design one. Okay, now Tally is saving two things. So it's saving a PDF report and an Excel report. The information is exactly the same in both places, but the PDF report has all of the methodological information, all of the text and write-up that you would probably want to have if you were handing this over to your client, or for something like the LEED submission. It includes all of the documentation with all of the details of how the tool works as well, and all of your specific material selections. For the Excel part of things, it's basically just giving you all the detailed results. Not sure why this is stuck right now. Got stuck because I had the same PDF report already open. So anyway, you get the PDF report and the Excel report. The Excel report just has everything, all of the numbers accessible to you, so you can potentially create your own diagrams if you want it. I'll start with the PDF report. So here, this is blank because I didn't actually provide an image of the project, but you could do that. On page 3 is where you see the first set of results from Tally LCA. So here, you can see the upper table is the absolute values, and we include the global warming potential as well as the additional environmental impact categories, which is something that I just mentioned a second ago. Again, embodied carbon footprint is the global warming potential part. Most of the time, you will probably want to look at, again, per area impact. And this number right here, the product stage impacts, should probably be somewhere between 200 and 800 kilograms of CO2 equivalent for a new construction project. But again, you could compare this number more accurately to, let's say, the EPIC assessment from earlier, right? So I think the EPIC assessment from earlier, I actually have another spreadsheet. So I'm switching between a lot of sheets here, but I do want to show you the comparison. So I did this before the session. In the base scenario of the EPIC assessment, the A1 to A3 kilograms of CO2 equivalent per meter squared was about 926, including the entire scope, including the MEP systems, interiors, etc. If you remove the MEP scope and the interiors and just focus on structure and envelope, it put me at about 470 kilograms of CO2 equivalent per meter squared. Now, with the initial Tally LCA assessment, we're at about 627, as you just saw. So you see that those numbers don't exactly align, and that is just the kind of the result of going from historical results from other projects that may be simplifications to something more specific where you actually have a fully designed building with all of the components put in place. The one thing that I didn't actually do on this project is also confirm that there's no duplication of elements. One thing that sometimes can happen in Revit is if you have a structural engineer, an architect, having separate models, sometimes the floor systems get duplicated. So these are some of the aspects that you will want to go through with your team, with the architect and the structural engineer to make sure who is responsible for which elements on the project, and then whoever is doing the quality assurance that they actually check that there are no overlaps and duplicates between elements. Typically, the early estimates from tools like Epic just have also large uncertainty, which is not necessarily shown. So I think the typical range can be plus minus 25% from those, early estimates. And I think this is within maybe a 20% difference, if I remember correctly. So those are just some of the things to keep in mind when you're actually switching between one tool to the next. Some of these differences in the quantity estimates and in the total impacts. Now, what can you actually do with Tally LCA once you have these results? So the first thing you can do is go and look at a more granular analysis of where some of the impacts are coming from. So a couple of pages later, you have these bar charts with the individual environmental impact categories, and then you see the contribution from different material types to the overall project. We have this 54% impact in this light yellow color here, which is obviously something that we should probably look into. And it seems to be one of these concrete materials. I'm not quite sure which one, so this is where actually the Excel report might come in handy. So I'll again switch one more time, one of my screens. Now we're going to be looking at the Excel report. And here I can go into the stage and category sheet. I think that was the one that we were looking at. Oh, so it was probably the division and tally entry. Okay, that looks better. And we see the same concrete material types here. We see that the cast in place 4,000 PSI is actually the highest in that global warming potential impact. And so now knowing this, we could do a couple of things. We could see, okay, are these systems where we could actually substitute concrete with some other material? Or later on, once we actually look at EC3, maybe we could just tell the concrete suppliers to, that you are calculating the embodied carbon footprint of your project and ask for suggestions on any low carbon mix designs that they may provide. So those are two options that you could do. So in order to know where this cast in place concrete is actually within the building, I can go to the back of this report and look for concrete cast in place 4,000 PSI. Going into the documentation section in the back of the report, going to see structural concrete 4,000 PSI. And now I can see where exactly that concrete is. So it's in the concrete deck. It looks like probably some wall systems here, or probably some floor systems. And then the concrete frame. Right, so that you can see that you have 5 million kilograms of concrete. That's a large amount of concrete on the project. Okay, so what we could do from a design perspective is consider some alternative designs, probably for the slabs or for the frame. Now this can get pretty complicated, so I won't go into the details of how you actually come up with different structural designs. But if you did have different structural designs modeled in Revit, you could do that quick comparison again using LCA. So I have my structural model here, and in the Revit design option comparison section, I have 4 setups of different structural systems. I have concrete, steel with white flanges, steel with hollow sections, and then timber frame. Now keep in mind, these are not actual designs, so some of the results may not be you know, realistic, but this is just to prove, or show you how you would go about using the tool to actually compare some of these design decisions. So I have those designs selected. I can actually show you if I switch the design options in Revit. You can see now we have the white flange sections. And now we have the timber frame sections. And if I go into Tally LCA again, I could now go into design option comparison, select all of the design options, click on apply. Now I've already gone through this exercise once, so I've defined most of the materials on this project. I actually changed the wide flange sections, but that's okay. And so you have all of the materials defined on the 4 different design options. At this point, you can save a report. I'll streamline this a little bit. Save the report. Okay, and now we have a similar PDF report, except now you will see multiple design options here lined up side by side. So we'll go to one of the additional charts here. Look at it by material type. You can now see option 1, concrete, option 2, hollow structural sections, and option 3, timber. You can see the impacts from global warming potential perspective of these different entire structural system designs. So this is another way that you could use Tally LCA. And at this point, if you do compare one set of assemblies or structural systems, then you can make a design decision to, for example, go with mass timber frame, right? Or you can go with a specific type of envelope system or exterior wall system that seems to be the lower carbon footprint. Again, understanding that these are all using average material impact information. There will probably be an additional step where you can add additional carbon reduction aspects once you start selecting specific producers of some of these materials. So at this point, I think we kind of wrap up the design phase of how you would go about doing a LCA on a building from a design perspective and actually compare different design options. I do want to, so I'll open it up to questions, but I also want to stress that, again, you don't have to use Tally LCA for this. There are many other tools. For example, the Athena Impact Estimator, which is a standalone tool, allows you to do some of these comparisons as well. It's just the process of defining the materials and estimating the material quantities is different. You can also use tools like the Payet Kaleidoscope tool, where someone else has already gone through the process of having assemblies, put together, tally materials assigned to them, and then just give you the final results of all of the different assembly options. So I'll change it over to Kaleidoscope carbon I'll drop the link into the chat. And here, you actually don't need to model the entire building. You can just go and look at some of the predefined designs that the Pied architecture firm has put together. You can quickly see the overall carbon footprint of some of these systems, including all of the various layers that would be typically included in these systems. So again, if you have your own standard systems that you use within your design firm, then you can use Tally LCA to do it yourself. Otherwise, if you're just looking at other people's work, this is a great resource as well for you. And this is, again, completely free to use. Any questions for the design aspects from anyone? If not, I'll switch over to the last portion of this whole walkthrough, and that is the product-specific material selection and anything that you would do at the construction phases.
Vaclav, there is a question about purchasing carbon offset credits and if that could factor into embodied carbon calculations.
Yeah, that's a great question. So carbon offsets are typically not allowed in EPDs or in whole building LCAs. Now, we do get this question more often nowadays as more people are interested in this, right? They typically try and address the energy efficiency of their production lines the best as they can, and then they try to get to a net zero operating company by purchasing offsets for the rest. But normally you wouldn't actually see those carbon offsets reflected in EPs or whole building LCAs because it's definitely not a robust system enough right now. So yeah, typically you wouldn't actually come across carbon offsets in terms of whole building LCAs or product LCAs. It typically happens more when companies are trying to make claims about being net zero net zero companies sometimes. Now, there is one thing, and that is the ILFI zero carbon certification, which actually, I believe, requires you to purchase offsets for any of the carbon footprint of your building that you have. But again, it's essentially saying, do your life cycle assessment of your building, give us the actual carbon footprint related to all the materials that you're putting in place. And then on top of that, you are responsible to purchasing carbon offsets to essentially just satisfy the zero carbon certification. Again, it doesn't mean that your building is actually zero carbon. It's just that you've gone that extra step and paid someone else for potentially sequestering that additional carbon that you just weren't able to avoid. But avoiding carbon emissions in the first place is always the priority. Okay, so if that's all there is in terms of questions, let me switch over to the last section of the day. I know we're a little bit behind, but this course was scheduled for up to 2 hours, so I hope everyone's still okay with staying on. And let me switch over to here. So now, what do you do in the construction phases where most of the design is probably set, right? You can't do too much about changing the actual structural frame or the shape of the building and different systems. All of the material quantities are pretty much set. What do you do then? You can still go and compare products for the materials that were put into the design drawings in the first place. And you can still sometimes find good amount of reductions just by selecting specific product types or specific manufacturers of those products. So this is where EC3 comes into play. EC3 gets all of its data from environmental product declarations, and it's really focused, it's just focused at this point at the carbon footprint because that's where EPDs are actually aligned. And it's trying to give you this understanding of, let's say you need the embodied carbon footprint of 1 meter cube of concrete. There is actually a wide range of potential impacts per unit of concrete that you can purchase on the market. And so EC3 will allow you to understand that range, and it also allows you to now take a look at individual product options that are on the market with EPDs and potentially either set specific thresholds for the carbon footprint of a unit of material, or actually put into the specification the preferred products that you want to put into your building. So there are multiple approaches. It just depends on what type of material or product you're talking about. So now let me switch over to EC3. You can get to EC3 by going to buildingtransparency.org. And then you can register for free. Again, this EC3 tool is completely free to use. And then you would just sign into the tool. I'm just going to open up my other tab here, go into the landing page. So on the landing page, you will see where most of our data is actually coming from. We include EPDs from around the world, but we really started with focusing on North America. That's why you see the most EPDs in North America. You can also see which product categories we have the most data for. So concrete finishes, thermal moisture protection, asphalt, steel, etc. All the high impact categories we actually have the most data for, which is good. There are some categories that have less data, but there's more and more EPDs that are coming online. Now you can simply look and see what we have in terms of EPDs in the individual categories, but by going into find and compare materials, and to go into the material categories, for example, reinforcing steel, select that category, go into next. Now, don't get overwhelmed by this page. You could simply click on the search button here, and that will search for all of the EPDs within the rebar category. But when you're doing these searches for materials, and you're doing LCAs, you always want to make sure that the performance characteristics of those products actually meet the design intent and the design requirements, right? So that you're not actually designing with less quality products, or for example, that the compressive strength of your concrete doesn't actually meet the specification. So that's why we have some of these selections here. You can go and look for specific products that meet the performance specifications. In this case, we'll just go with the basic search without any specific performance specifications. You can see that the embodied carbon footprint per kilogram of rebar typically is between 0.6 kilograms of CO2 equivalent per kilogram of rebar up to 1.6. But there are some high impact materials up here up to 5.8 kilograms of CO2 equivalent per kilogram. So those are usually outliers. There can be some specialty products that are that high. Most of the impacts are going to be in this range right here. So when you're putting together specifications and you're wondering if you should set some sort of thresholds for products that you will try to hit, this information could be useful. So you could set thresholds based on the search of the products that you think are available in your market, which is another topic that I'll touch on in a second. Or you can set a target that you're trying to go as low as 0.6 kilograms of CO2 for all rebar, and kind of put that into the specifications, or even consider that during bid, and say if there's a supplier that can meet or get close to that goal, they will be, for example, prioritized for selection during the bidding process. So there are various approaches that you can take, but you also need to understand what the realistic range of values per unit of these individual materials may be. And this is where you can get that information. Now, if I scroll to the bottom of this page, you actually see the individual EPDs listed one by one, and you can see the GWP values here in this column. Now you can see that in this case, we also have a lot of non-US based products. So I could go up here and select geography Americas, or I could go even further North America and click OK, redo the search, and find those same products. Now you see that this range of realistic values is actually adjusted to represent just the products that are actually made in North America. If I scroll to the bottom, you can now see that all of these are made in North American mills. If you wanted to compare individual products, so even though you can see the numbers here, you can click on the compare button. Oops. I double clicked it, so it went back. You can click on the compare button and select multiple EPDs here. And then if I scroll back to the top, you will see them lined up side by side. You can quickly see how they compare to the rest of the category and how they compare to each other. In this case, you can see actually that there's a lot of overlap. There's not a significant difference in any of these suppliers per se. So they all have very similar carbon footprint values. Any questions so far? Otherwise, I will actually switch to a different part of EC3 where you can actually combine the individual EPDs with the material quantities on your project, and again, get to that overall carbon footprint of your project specifically.
We have one from Michelle wondering how often the CLF baselines are updated.
Yes, so the CLF baselines are updated about every other year, I think. They first came out in 2019. There was a 2021 version, and the most latest one is 2023 version. And I know the CLF, the Carbon Leadership Forum, is currently working on another version, which will probably be 2025 most likely. Now, the note that there is an important note that the methodology of the CLF baseline has changed significantly in this latest version, where in the past, they've actually tried to align the baseline with the conservative, the 80th percentile of the market. In the latest version, they're aligning it with the average of the market. So there's a shift in essentially what those numbers represent, CLF baseline numbers. So it's just one thing to note. I think I might be able to actually demonstrate it here. Go back and do a general search. Right, so right now the 2021 CLF baseline listed here is 1.7 kilograms of CO2 equivalent per 1 kilogram. I can change the baseline using this gear icon and then go into 2023 industry average. And I think, let's search, so 2021. Interesting. Okay, something is broken. All right, I think I'll show this on the project side. So I think there's a setting in my user profile, and I think my default is at 2021. That's why it's keep coming back to it. I'll come back to this in a second. But basically, just understand that the methodology behind the baseline has changed. So if you're setting your targets or your reduction, goals and ambitions from those goals and ambitions will be very different if you're using the 2021 CLF baseline versus 2023. There's probably going to be about 30% difference because 2021 again was set at the 80th percentile. 2023 is set at essentially the 50th percentile. Okay, now what I did want to show is in the plan and compare building section of EC3, you can actually go and do a more holistic assessment of your entire project and actually document all of your material selections on your project. So you can start from scratch by clicking on the building project button here, start from building project. There are a number of different ways that you could actually get material quantities into EC3. But the most basic way would be to start from scratch. Now, let's say we have, again, 3C RAM blank project. Start with that. Now you can select project address again, just like you did in the two other tools in California. And you can add additional building classification information, etc. Now I'm going to skip over this part. This is more for bookkeeping purposes. Again, if you're trying to benchmark projects. The most important part of this project interface is at the bottom of the page. You do also want to still fill out the gross floor area. And this tool actually understands if you type in feet squared or meters squared, it will understand the differences in those units. So just make sure that you just type it in. 3 floors, and those are the most critical fields. Now let's go all the way to the bottom. Now this is structured in a uniformat structure right now, and we just kind of give you a template to start. You can open up all of the individual elements, and you can see that it's structured very similarly as what we saw in Tally LCA. You have individual systems, individual elements, and then you can start adding quantities and start linking EPDs. So if we started from scratch and we wanted to, for example, do capture concrete, 4,000 PSI or 5,000 PSI in the foundation, and let's say we have 100 cubic yards, Okay, so now we have the quantity. Now we can click on the EPD button, select the category, concrete, ready mix, next. Now we said it was 5,000 PSI, so in this case we actually do want to fill out some of the performance specifications as 5,000 PSI. Enter. Now in concrete, this search takes a little bit longer because we have about, I think, 100,000 EPDs in concrete specifically now. There's a concrete generator that companies are using now, so they're able to quickly generate large amounts of EPDs. Now, again, the range of impacts here typically is between 314 and 470 kilograms of CO2 equivalent per cubic meter of concrete. The reason why this is in meter cubed is because my basic setting is an SI unit still, but it doesn't really matter for the quantity on the project. Again, the tool understands those differences. Let me scroll to the bottom and click on search. And now you see we have 13,000 EPDs that fit the 5,000 PSI specification. Now, concrete typically comes from a specific distance from a project site, right? It's not shipped around the country. So in this case, for concrete specifically, you can enter max distance from project site here. I'll say 30 miles, which will take into account that it's in Oakland, California. Search again. Scroll back to the bottom and you see that we only have 1,400 EPDs now. And if I go back to the top, the range has probably shifted slightly as well, 272 to 383. And I can go to the bottom and I can again see all of the EPDs here now. This is going to be a little bit hard to navigate because all you see is the product mix designs. So sometimes it can be a little bit hard to actually select which product mix to use in your project. This is where I said earlier, it's in some categories, it's best to leave it up to, let's say, the concrete supplier or the subcontractors to actually figure out what is the best low carbon product that is available within your market. So in some cases, it's best to just say and require the calculation of embodied carbon either by the sub or require the sub to ask for environmental product declarations to whoever their supplier is. In some cases, you can also provide an EPD request letter directly to the manufacturer of the product or the supplier. And we also have some template EPD request letters for you to use as well. All of those links will be in the slides, which will be shared with you after the course. Now, let's say we actually wanted to select one of these products. It's as simple as clicking on the row. Actually, you need to click on the start button here and click on selected. For example, I just selected this Berkeley mix, 1536066. You can also select alternative materials, just as placeholders, if you wanted to consider additional products. And now if I scroll to the top, I can show alternates, and I can again see side by side what the impacts of the individual products are. Now the selected product is this one. So that's actually not a low carbon product, but that's okay. Once you're done with the selection, you click on use this collection. Now you will see the product category that this is in, and you can also see the specific product that we selected by clicking the toggle up here. So we have the Cemex specific mix design, and there are also two other alternatives. So this is essentially, again, you would go through the entire project, select all the materials, define all the material categories. And in some cases, we also have additional calculators that help you estimate material quantities again. So if you wanted to, for example, estimate the amount of concrete per area of a slab, let's do square feet. Let's say we have 1 foot thick slab, then this should help you calculate the total impact. It's a little bit confusing because I still have the SI unit setting here. Let's do meters squared, 0.5 meters. Okay, and you see that this helps you calculate the quantity. There's actually a 3% overpour here. That's why we get the 3 in here as well. And so we have additional calculators throughout the tool as well for example, studs, metal decks, etc. Now, last thing I think that I will show in EC3, we'll take a look at a specific project that has been actually fully defined. So I earlier, again, when I was kind of preparing for this course, I exported all of the material quantities from Tally LCA into EC3. And so I was able to actually reuse some of the modeling that was done in Revit to get material quantities for that specific project that we've been talking about all day today. So let's let this load a little bit. Now, this is right now shown in the master format setting, but you can also switch the view by unit format or custom format. I didn't actually organize it in unit format in this case. So I think if I do that, it's just going to all be under other. But if you wanted to, you could go and reorganize it in different ways. And you can see that we have the individual material types. We have all of the quantity estimates that have been transferred. And we also have the types of materials predefined just based on the setting that was already selected in Tally LCA. Now, if we look at the overall project impacts here, and click on the chart setting, and we can look at the Sankey diagram, for example. Now, this actually is not super helpful, but at least it's a little bit simpler. What's happening here is that on the left side, you have the individual material types listed, and then the size of the bar is the contribution of the global warming potential to the rest of the project. Now, for example, we can see that ready mix overall has the largest amount of contributing impact to the project. And if you think about earlier that box plot diagram where I was saying that we have a range of impacts from the from the lower impact of a typical concrete mix to the higher impact was about 230 to 400 kilograms of CO2 equivalent. That is the range that you see here. So this is the range between the conservative estimate and the most achievable estimate. Now on this project, before our course, I actually went in and I found the element that contributed the most to the overall project footprint, and I selected a very low carbon mix design. And that is what the selected line means. So I actually selected something that was in the best 20th percentile of the market. Now, again, that was just to show you how this tool would actually reflect that information. You can also see this information in the Excel reports. So I'll clear my drawings. Oops, now I stopped sharing completely. Okay, so we're back. All right, so I'm going to close the chart. There are a couple of different charts that you can use. Also point out the user guide for EC3 if you just want to be able to take your time and walk through everything at a slower pace. But for now, we'll switch over to reports. So we need to save the project. We'll go into reports. Now, again, there are a couple of different options for reports. You can export just the full list of the EPDs that were selected on the project. You have various policy-related reports. The most comprehensive and the most basic report that you can use is this building element report. That will essentially list all of the individual line items in the project and provide you with all of the embodied carbon footprint values that the tool actually calculates. So I'm going to open up that Excel report. Okay, so now we have the list of individual elements in the project here. You see that we have all the quantities. So this is all the same information as we just saw in EC3. And then on the right side here, starting in columns G, H, I, you have different types of embodied carbon values. So this one is the carbon leadership forum baseline value. This is usually what people like to compare to. And then we have the conservative estimate. This is if you didn't make any product-specific selections, like selecting that specific mix from a specific plant, like I did, right? This would be your starting point. So that essentially assumes the 80th percentile scenario for each of these line items, and it gives you that sort of starting point for the embodied carbon footprint of each element. Now, if you make any product-specific selections, then those lower carbon footprint values would be reflected in the realized column. So you see that for most of these, the values actually don't change between conservative and realized. And that's because I didn't make any product-specific selections. But there are a couple where the numbers do change. So here I actually selected a higher impact material, which is not great. But let's see where we have there was a concrete, I think it was this one. So originally, before selecting that specific mix, we had, I think it's about 1 million kilograms of CO2. Then I selected the low carbon design and we ended up with 452,000 kilograms of CO2. So you can see that that's a significant change. So all of that would be reflected here. And also, because I selected that specific mix design, that information is linked here. And if you wanted to, for documentation purposes, that this can take you back to EC3 as a evidence of you selecting that specific product. So essentially, if you're at the S-build stage, you would want to have as many of these product-specific EPD line items filled out as possible. And obviously, you would want to make sure that most of them are lower carbon than what you started with. I think that covers the basics of EC3 and how you can use it for actual specific material selection. Now, a couple of closing aspects before we wrap it up here. I think we only have a couple of minutes left. So thank you for everyone who's still sticking around. I know it's been a long session, but let's come back to our overall analysis, using all of the different tools and conducting the assessments at various stages of design. So we started with the Epic tool. Let's kind of disregard the first line item because the scope didn't really align with the rest. But we did start with estimating about 470 kilograms of CO2 equivalent per meter squared. And that was, that was for the structure and envelope system specifically. Then we moved towards Tally LCA. We did some initial analysis. So let's say we had that full design analysis, right? We came up with 627 kilograms of CO2 equivalent. I actually included another stage here. So let's say you made a design decision to go with a different structural frame design. You could obviously, redo that whole analysis and record that number here, and you would see that, you would see what the change is from one step of design to the other, again, using the same tool. Now, later here, we transferred the schematic design Tally LCA material quantity information into EC3. And initially, actually, the footprint was about 567. There will be a little bit of a misalignment again in the scope because EC3 does not have all the same material types as Tally LCA does. That's a small caveat there. But generally, once we went into product selection, we started at 567 kilograms of CO2 equivalent. And after all of the product-specific selections, we ended up at 464. Now, you will obviously not always be able to, achieve all of the design aspirations that you may have set out to at the beginning. You may not always be able to produce or procure all of the materials that are lowest carbon. It just depends on the supply chain, aspects. And, there are obviously regional aspects to some of these topics as well. So sometimes it's hard to, pursue the same strategies from one project to the next. And that's why it's best to try and do this on every project. And just also kind of just learn from what worked and what didn't on previous projects. Another nice thing is that when people do these as-built assessments, there are various ways that you can actually report those impacts back to places like the Carbon Leadership Forum or the SC 2050 group that are collecting all of the data for life cycle assessments of buildings that everyone in the industry does, so that they can then further improve the early assessment tools like Epic, for example. So I definitely encourage everyone to go as far as to the as-built phase, as-built accounting with this embodied carbon assessment. Now, a couple of closing slides and also, any last minute questions if you have. Again, just stressing that the uncertainty early in design is going to be much larger, right? So we saw, for example, we were at a lower number than later in design and later in construction in that specific case study. So just keep that in mind as well. There's always some larger uncertainty at the beginning of the design. And there are some basic ways that you can lower the embodied carbon footprint of your projects. Reuse of buildings, reuse of products, then you can optimize this design and then choose materials and products. So all of these goes, in tandem. Different individuals on the design and construction teams obviously have different ways that they can contribute to the overall carbon footprint of the projects. So I'll stop here, open it up to any last questions, and also just hand it back to Ian for any last closing remarks.
Awesome. Thank you, Vaclav. Super thorough. I guess I'm curious as LCA becomes part of code in California, do you think there will be, just based on the sheer volume of LCA tools coming out, do you think there will be a universal one, or will it kind of continue to be a plethora of options?
I think it's still going to be a plethora of options, but there are some standardizations that are going on right now as we speak. There is a standardization of how elements and systems are actually described in some of these assessments, so that, you know, if you do an LCA in one tool, you can more easily compare it to another tool. There's also more and more alignment in the data sources. So we as Building Transparency actually, in collecting all of the environmental product declaration data, we are opening it up to other tools to use that same data, so that we pull from the same pool of information on the individual, you know, product level.
Mm-hmm.
Again, that's easier to align on the carbon footprint front than some of the other environmental impact aspects. So there are, you know, sort of multiple ways that we need to address the alignment of different tools. But I think there will always be a variety of tools available. I know right now it can be a little bit harder to choose the right tool because there's so many new ones popping up all the time.
Yeah.
But I think that will also just, you know, steady out as well.
Okay. Yeah, I think that's the motivation of hosting this webinar in particular, is just kind of honing in on a few options.
Mm-hmm.
We do have one other question from Michelle. Are there tools that can give good data on MEP systems?
Yes. So we are actually working on collecting more of that data in EC3. Those categories are just not publicly visible yet. There are more efforts from mechanical and engineering firms on collecting that data from their suppliers, or even when they're designing equipment for MEP. There is an ASHRAE standard that is I think it's still in progress in terms of being developed, but essentially will provide a methodology framework for anyone that doesn't have an EPD on an MEP system, how they can actually use a simplified approach of trying to estimate the embodied carbon footprint of that equipment. And I think even whole building LCA tools will start to add MEP systems into the mix. Obviously, MEP systems can have significant carbon footprint. There's a lot of metals, which are typically high impact materials. So I think in terms of specific tools that today address MEP systems, I think one-click LCA has some data, and they also just opened up this simplified carbon footprint estimator for the manufacturer to be able to provide data as well. So it can be a little bit scarce today, but we're getting there. We're heading that way.
Awesome. All right. Well, we won't keep you too long over 5 o'clock. Just some closing remarks. We did have AIA learning units available today. Also, if you would like a certificate of completion for zero net carbon design learning units, we can provide those as well. Just reach out. My contact email is here, and should be on some correspondence between us. I will send out slides and a recording from today, likely tomorrow. It should go out sometime over the weekend. So you will receive those, a survey as well. If you'd like to take that, feedback is always welcome and used. It helps us kind of, customize these things to what's relevant to our local industry, and that is why we're here. Quick shout out, our Q1 quarterly events calendar was just released a few weeks back. So our website is full of courses. We've got, 1 to 2, maybe 3 classes per week for the next 4 to 6 months. So be sure to check that out and please share with your colleagues. All circulation is appreciated. Otherwise, we can leave it at that and enjoy the rest of your evening.
Thank you, everyone.
Thanks all. Thank you, Buck Club.